are the semiconductors which are obtained by adding impurities. These are called as extrinsic semiconductors. Next, N-type semiconductor, P-type semiconductor. N-type semiconductor means these are the semiconductors or the electron rich impurity such as nitrogen, phosphorus, arsenic, antimony, bismuth. So these type of impurities is added to intrinsic semiconductors. Then we get N-type semiconductor. If group 13th elements such as aluminum, boron, gallium is added to intrinsic semiconductors, then we get P-type semiconductors. Okay. So these are the classification of solids according to conductivity. Just I have explained generally. Now I will explain these terms based on the specific conductance values and based on the band theory. Just see here, solids conduct the electricity. Their conduction can be compared by knowing their specific conductance values. We can easily define conductors, insulators, semiconductors based on the specific conductance values. Specific conductance or conductivity, both are same. The solids with a conductivity ranging between 10 raised to 4 to 10 raised to 7 per ohm per meter, that is called as conductors. The solids with a conductivity ranging between 10 raised to minus 20 to 10 raised to minus 10 per ohm per meter, those are called as insulators. The solids with a conductivity ranging between 10 raised to minus 6 to 10 raised to 4 per ohm per meter, those are called as semiconductors. Per ohm per meter is a unit of specific conductance. And in detail, you are going to study in electrochemistry chapter about these specific conductance, conductivity, resistance, all the things you will study in electrochemistry chapter. Metals having conductivity order 10 raised to 7 per ohm per meter are very good conductors. Okay. Now move on to the band theory. First we have to understand about the band theory. Just carefully listen this concept. Metals conduct electricity due to moment of electrons. Molecular orbitals are formed by the combination of atomic orbitals. As you studied in chemical bonding chapter in first PUC, molecular orbitals are formed by the combination of atomic orbitals. If n number of atomic orbitals combine, then n number of molecular orbitals are formed. All these molecular orbitals have nearly equal energies. Their energy level are very close to one another. They form energy bands such as lower energy valence band and higher energy conduction band. See here, solids having two types of bands: lower energy valence band, higher energy conduction band. For example, silicon. So silicon, it is a, see here, 1s2, 2s2, 2p6. It is an electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p2, 3d0. Silicon having atomic number 14, it is electronic configuration. So 6 plus 2 plus 2, 10 plus 2 plus 2. 10 plus 4, 14. Okay. Here, these are the valence electrons. Yes, third shell is a valence shell. And third main shell having S, P, D subshell. S and P subshell having the electrons, whereas D subshell doesn't contain electron. Hence, these 3s and 3p orbitals having electrons, these S and P subshell form valence band, whereas 3d subshell form conduction band. Just I have taken only one example here. It is same for all the elements. So these 3s 3p orbitals having electrons, hence valence band is a partially filled band. It is a partially filled band. Conduction band is a empty band because it doesn't contain electron. If electron jump from valence band to conduction band, then it conducts the electricity. If electrons cannot jump from valence band to conduction band, then it doesn't conduct the electricity. It do not conduct electricity, hence it is act as an insulator. If electron jump from valence band to conduction band, it is act as a conductor. If electron cannot jump from valence band to conduction band, it is act as an insulator. So in detail, we can easily study that by knowing the energy gap between the valence band and conduction band. Just see here. Just see these three diagrams. Here energy gap is very small. Here energy gap is very large. Here energy gap is small. This is a valence band. This is a conduction band. This is the energy gap, or it is called as forbidden zone because here electron will be not there. This is in a metal. This is in case of metal. It is in case of insulator. It is in case of semiconductor. If the energy gap between valence band and conduction band is very small, since due to that reason electron can easily jump from lower energy valence band to higher energy conduction band, hence it conducts the electricity. Those are called as metals or conductors. If the energy gap is very large between the lower energy valence band and higher energy conduction band, so electrons cannot jump from lower valence band to higher conduction band, hence it is act as an insulator. Here it do not conduct the electricity. Here energy gap lies between conduction band and lies between insulators and metals. Or here energy gap is small. If you given the temperature to this semiconductor, then only electron can jump from lower valence band to higher conduction band, then it conducts the electricity. But at room temperature, it is act as an insulator. See here, the energy gap between valence band and conduction band is small, hence electrons can jump from this valence band to conduction band by increasing the temperature or by the process of doping. Hence these are called as semiconductor. This semiconductor, it may act as a conductor as well as it may act as a insulator, hence this is called as semiconductor. So in detail this concept only I have written here. Just see here. Metals are conductors. The electrical conductivity of metal is due to the moment of valence electrons. In metal, the energy gap between valence band and conduction band is very small, or sometimes they overlap. So electrons easily move from valence band to conduction band. Hence, metals are good conductors of electricity. Example, copper, silver, gold, aluminum. These are the good conductor of electricity. In solid state, these metals conduct the electricity. See, as I said already, the valence band, conduction band, it is a partially filled, it is a empty band. The electrons, the energy gap is very less, since electrons can easily jump from this level to this level, hence it conduct the electricity. Insulator, as I said already, in some solids, energy gap between valence band and conduction band is large, so electrons cannot jump from valence band to conduction band. Such solids are called insulators. Example, rubber, plastic, wood, etc. As I said already, here the valence band is a conduction band. The energy gap is very large, hence electron cannot easily jump from this level to this level, hence it do not conduct the electricity. These are called as insulators. Next is semiconductor. It is also I have explained here. In some solids, the energy gap between the valence band and conduction band is small, so the electrons can jump from valence band to conduction band by increasing the temperature or by adding impurities, are called as semiconductors. See here, it is a valence band, it is a conduction band. Between these two bands, the energy gap is small, so electron without giving the temperature, electrons cannot easily jump. If you given the temperature to this semiconductor, then electron can easily jump from this level to this level, or instead of giving temperature, you can increase the conductivity by adding impurities. These are called as semiconductors. Again, semiconductors are of two types. One is intrinsic semiconductors, another is extrinsic semiconductors. Intrinsic semiconductors means these are the, already I said you, these are the semiconductors which conduct the electricity in its pure form. Those are called as intrinsic semiconductors. Example, silicon, germanium. Or you can say it as the substance which are insulators at normal temperature, but they become good conductors by increasing the temperature, are called semiconductors. Here we are not going to add any impurities. Only pure silicon crystal is there here. Just we increase the temperature of this crystal. As the temperature increases, what happens here? The bond between the silicon atoms are break, and free electrons are move from this position to this position. If this electron is moving from this position to this position, then the electron present in this position, this is moved from this position to this position. Like this, electron delocalization takes place in the crystal. Then conductivity takes place in this substance, hence it is called as intrinsic semiconductors. Then what do you mean by extrinsic semiconductors? Extrinsic semiconductor. Before understanding the meaning of extrinsic semiconductor, first we have to understand doping process. Doping. Doping. What do you mean by doping then? It is a process of addition of impurities to the intrinsic semiconductor to increase the conductivity. That is called as doping. Once again I will repeat. It is a process of addition of impurities to the intrinsic semiconductor to increase the conductivity. That is called as doping. The semiconductors obtained by adding suitable impurity to the intrinsic semiconductors are called extrinsic semiconductors. Extrinsic semiconductors. Again, doping can be done in two ways. First one is by adding electron rich impurity, and another way by adding electron deficient impurity. Doping can be done in two ways. Electron rich impurity is added to intrinsic semiconductors, and electron deficient impurity is added to intrinsic semiconductors. This here, if you added electron rich impurity to the intrinsic semiconductor, then we get n-type semiconductor. If we added electron deficient impurity to the intrinsic semiconductor, then we will get p-type semiconductors. Extrinsic semiconductors are of two types, n-type semiconductor, p-type semiconductor. These two semiconductors are obtained by the process of doping to the intrinsic semiconductor. Then what do you mean by n-type semiconductors? Just before going to this definition, let's just understand this. Silicon, germanium are the example for intrinsic semiconductor. Group 14th elements: carbon, silicon, germanium, tin, lead. Silicon, germanium are the pure semiconductors or intrinsic semiconductors. To increase the conductivity of these semiconductors, what happen? We have to do here doping. See, if silicon or germanium is doped with the group 15th element such as nitrogen or phosphorus. These are called as electron rich impurities. Then we get n-type semiconductors. Once again I'll repeat. If silicon or germanium doped with electron rich impurities such as nitrogen or phosphorus, then we get n-type semiconductors. And the group 13 elements are called as electron deficient impurities. If silicon or germanium are doped with electron deficient impurity such as boron, aluminum, then we get a p-type semiconductor. First I'll explain n-type semiconductors here. Just see here, it is a pure silicon crystal. So already you know that silicon having 4 valence electrons. 4 valence electron uses for the formation of 4 covalent bonds with a neighboring silicon atom. Whereas you know that already group 15th elements having the 5 valence electrons, phosphorus having 5 valence electron. The silicon is doped with the group 15th element, that is phosphorus. Since it contains 5 valence electrons, 4 valence electrons are involved in bonding with the 4 electrons of 4 silicon atoms. So 4 covalent bond formation takes place between phosphorus and 4 silicon atoms, but 1 electron is excess. That is act as it is responsible for the conduction in n-type semiconductor. So once again I will repeat this. When silicon is doped with the phosphorus, silicon form 4 covalent bond with the 4 electrons of the phosphorus. The 5th electrons of phosphorus is extra and become delocalized, which conduct electricity. So in n-type semiconductors, the charge carriers are electrons. In n-type semiconductor, conductivity increases due to negatively charged electron. Then in p-type semiconductors, that is only I have written here. See here, the semiconductor obtained by doping impurity atoms like phosphorus, arsenic, antimony, bismuth to tetravalent silicon, germanium are called n-type semiconductors. P-type semiconductors. See here, when silicon or germanium doped with electron deficient impurities such as boron, aluminum, gallium, then we get p-type semiconductors. Just see here, this is a pure silicon crystal. This silicon is doped with the group 13th element, that is boron. Boron is having the 3 valence electrons. So 3 valence electrons are form 3 bonds with 3 silicon atoms. and one electron vacancy is created. This is the one electron vacancy is created, hole. This is called as hole. Hole. This is called as p-type semiconductors. Once again I'll repeat this. When silicon is doped with a boron, silicon form only 3 covalent bonds with a boron, which creates hole or electron vacancy. So in p-type semiconductor, holes are the charge carriers. In p-type, conductivity increases as a result of holes. Thank you, students. Next class the solid chapter is got over here. Thank you so much.